Okay, this is part 2 of total surface area. We'll still be using the same sheet, still be using our formulas. This is where that blue information becomes very, very important. With today's questions, we'll only be using parts of each formula, some of each formula. It's up to us to work out which parts we need depending on what the shape looks like. So make sure you've got that handy. Okay. The first thing you'll notice about all of today's shapes that we're looking at is that they don't identically match up with anything on the page. It's still total surface area. We're still wrapping Christmas presents, so we're still trying to find out the total, imagine it's like the amount of wrapping paper you need to cover each side of this shape. But this time they're called composite shapes. That means they are two shapes that are stuck together. So I'll get you to draw something that looks a bit like that. So as you can see, it's got that shape on the top and it looks like a bit of a rocket. And it's connected to this shape there on the bottom. Okay, so there's our shape. Start by drawing that, please. I'll give you some measurements to label it as well. But as you can see, that's two shapes from our page that have been stuck together. All right? That slant there, that is 6 centimeters. That distance there is 11 centimeters. And the radius across the bottom is 5 centimeters. Label it the same, please. Okay, now, as I've said, it's two shapes stuck together. I want you to label the two shapes, so shape 1 and shape 2. So again, try and do it before I do, stay ahead of me. But we can see that there's a shape on the top that looks like a cone, so we'll call that shape 1. And then there's something down the bottom here that looks like a cylinder. We'll call that shape 2. Now, your working out must look exactly like mine. Let's start here with, shape 1. And over here, shape 2. What I would like you to do is write down the formula for the cone for shape 1 and the formula for the cylinder for shape 2. You can write the whole formula down and then we'll cross out the parts of the formula that we don't need. Do that now before me, please. Okay, we're now here. We've got our two formulas written down. This here is the formula for the total surface area of a cone. Now that's the total surface area of an entire cone. If you were holding it in your hand, it had a round lid on the top and then that cone part on the bottom. Look at this shape. Imagine you need to wrap this as a Christmas present, okay? You've just bought someone a rocket for Christmas and you need to wrap it. You can't see every single side of that cone, okay? You can only see that pointy bit. And that's where this formula, I know it's a bit blurry, but that's where this formula comes in. That's been split into two sections. See here our cone formula. It says that a part of the formula is for the circle part and a part of the formula is for the cone or the pointy part. When you've stuck these two shapes together, you can't see that circle part on the base of the cone. You don't need to wrap that part of the cone because it's on the inside of your toy, your shape, okay? So you don't need the part of the formula that is responsible for finding the area of that circle part. Cross out the part of the formula that you don't need. Cross out the part of the formula that is not visible from the outside when you're looking at this shape. If you crossed out that part there, that's correct. You don't need the circle part of the formula because you can't see it when you're looking at this shape from the outside. Now let's do the same thing with the cylinder shape. This is the formula for an entire cylinder. Like imagine you've got a can of Coke. This is the formula to find the total surface area of the whole can of Coke, given you can see every single side. We can't see every single side of this cylinder. As your formula sheet tells you, this part of the formula, that's for the two circles on each end. This part of the formula, that's for the cylinder part, or that round part there, the curved part. Now we definitely can see the curved part from the outside, so we definitely do need to keep that part of the formula. That 2 always stays there. That 2 never ever goes away. It's always there. This here though, this means two circles. Now look, if you're wrapping this as a present, if you're trying to find all the outer surfaces, can you see two circles? No, you cannot. You can see this one down here. You'd have to wrap the bottom, so you could definitely see that one down there, but you cannot see the circle that's inside here. You wouldn't need to wrap that top part of the cylinder because it's enclosed on the inside. So what you need to do is, you've only got one circle, not two. Make whatever adjustment you think you need to make to that formula if you only need to find one circle and not two. If you did that, you're correct. So now, let's rewrite our formulas only using the important bits that we need underneath. Go. Okay, now we've got the only bits of the formula that we need. We can work with here, and we can work with here. Let's start labeling our diagram. Okay, there's an R and an S, and there's an H. Quickly, put those letters on the diagram where you think they need to go. Your R is your radius down here, your H is your height there, and then your S, remember that's not a 5, that's an S for slant, which means the slanted part of the cone. Alright, now I would like you to rewrite these black formulas, but swap all of the letters for the relevant numbers. Go. Alright, if you're here, you're correct. You've put all the numbers in the right spots. The radius, it's the same down here as it is up here for the cone. Okay, so even though there's no number on that part of that circle, it's exactly the same as the one down the bottom there. So the radius here, the R's are both the same number all the time. Alright, that's all you need to do by hand. Your calculator will do the rest. Put those in your calculator and find the answer for the total surface area of each shape. Okay, that's what your calculator should have displayed if you typed in each of the equations. I've put centimetres squared on the end of each one, putting the units on there. I've kept it to 3 decimal places because we're not quite finished yet. With these sort of questions, it doesn't hurt to have a few extra decimal places on the end. And if you get tricked with rounding, do a quick search on to refresh your memory to watch a video on how to round off. But we will go to 2 decimal places at our final answer. Your answer is more accurate if you keep maybe 3 or sometimes 4 if you want 2 decimal places. Okay, we've found the total surface area of the cone. We've found the total surface area of the cylinder for the bits that we can see. We have one final step. Remember, these 2 shapes are stuck together. So what do you need to do with your 2 answers? You need to put them together. Do that now. See if you can work out what that means to put them together. It's 1 step on your calculator and your final answer can go down here. Go. If you added your 2 answers together, that is correct. And it gives you this final answer down here. It's been rounded to 2 decimal places. That is your final answer. That is how much wrapping paper you'd need if you were to wrap or cover this shape here. Okay? I do want you to write this step out. I know all you do is type it in your calculator, but to get full marks for your working out, I want you to write that plus these 2 numbers together is what you did. Okay? Alright, I'll wipe the board. We'll do one more. Okay, draw this shape please. It looks like a house, pyramid if you like, a box with a pyramid sitting on top of it. Draw this shape please. I'll give you some measurements to add on. Don't worry if your picture's not perfect, it's just a sketch for you to use in your notes. If I put little lines down here on each side, that means that all of those sides are the same length. So all I need to do is if I put a 7 down there, telling you that side is 7 centimetres, it means so are those other sides with the line on it. The only other bit of information I'll give you, and if you like I'll do it in a different colour so it stands out a bit easier, is I will tell you that height, if you like, of the triangle, so that triangle distance from there, from top to bottom, is 10 centimetres. They are the only 2 bits of information that you need, but let's do like before. We've got 2 shapes that have been stuck together. Label them shape 1 and shape 2. Do it before me, please. Okay, we'll call that pyramid thing up the top shape 1, and we'll call the box, if you like, down the bottom shape 2. Get your formula sheet. Decide what two shapes they are based on your pictures and write the formulas next to them here. Okay, shape 1, write down the whole formula if you like, and then we'll cross out the bit that we don't need and do the same for shape 2. Decide what shape it is and write the formula down the bottom there. Give you a clue, it's not a rectangular prism because all the sides are the same length. Go. Okay, there are our two formulas. That is a square-based pyramid, shape 1, and that's a cube for shape 2. So we've written down our formulas. We do need to change them a little bit because, remember, if this were a Christmas present you were wrapping, you can't see every single side. So let's start with shape 1. You can, if you look at your formula sheet, it tells you that this part talks about the square base and this part talks about the 4 triangles. If you look around, you can definitely see all 4 triangles, so we need to keep that part of the formula. But you cannot see the square base of the pyramid. So we don't need to keep that part of the formula. That L squared is talking about the bottom or the base of the pyramid. We can't see it. If this were a Christmas present we were wrapping, we wouldn't need to wrap the square base. So you can cross that part of the formula out. Now look at your cube. Why does this cube formula have a 6 at the front? Think about what you know. If you look at a cube, think about what you know about it. It has a 6 at the front because there are 6 sides on a cube. Look very carefully. If you were wrapping this as a present, if you were wrapping this shape, can you see all 6 sides as it is right here? You cannot. Change that number to how many sides you can see. Write your 2 new formulas underneath. This 6 needs to change to how many sides of the shape you need to wrap or how many you can see from the outside. Go. Alright, these are the 2 parts of the formula that we need. The 4 triangles. Flip back to your front page if you've forgotten, but half times base times height, that's the formula for a triangle. We can see 5 of the 6 sides of the cube, so we change that 6 to a 5. Okay, that's what's changed. Now, label on your diagram. We've got 3 letters here. We've got B, we've got H, and we've got L. The B means the base of the triangle, so that would go here. That would be the base of the triangle there. Now, there's no number there, but you might be able to work it out based on the other information that we've got. You need to know how long that line there is. H is the height of the triangle. That's this 10 up here. And then L, that's talking about our cube. That's the length of the cube, or that's this number just down here. Now I'd like you to rewrite each formula, swapping each letter for the relevant numbers. Go. Okay, that's what our formula looks like now. We've got all the numbers in place of the letters. Let your calculator do the rest. So if you've done that step right, you can now punch them in your calculator and you'll get an answer for each one. Go. Here we are. If you typed your answers incorrectly, you'll end up with these 2 answers here. We have one final step. We've found the total surface area of the pyramid part. We've found the total surface area of the cube part. The final step is, just like the shape, they're stuck together here. You've got to put those 2 answers together as well. Do that and you'll get your final answer. If you ended up with 385 centimetres squared, your answer is correct. Remember, it's always good to write that little step there as well for your working out. Okay, we'll do one more really quick shape and then you'll be free to work through your questions. Okay, here we have an ice cream cone looking thing. So a radius of 8 centimetres and that slanted part is 14 centimetres. Draw this shape please. It's 2 shapes stuck together. Label them shape 1 and 2 again. Okay, over here, write shape 1 and shape 2. Work out which formula or which shape it looks like from your formula sheet. Shape 1's a bit tricky because there's no shape that looks exactly the same as shape 1. Again, pick one that looks the closest and we'll change the formula however we need to. Go. Okay, we've picked these 2 formulas. Shape 1 looks a bit like a sphere, so like a basketball, but it's not quite a whole basketball. It's only half of a basketball. So what do you think you need to do to this formula? If it's not a full sphere, it's only a half sphere. There are 2 ways you can change this formula. It's a half sphere, so you can either divide the whole thing by 2, or you can just change that 4 into a 2, whatever makes more sense to you. Same thing over here. That's for the circle part of the cone, that's for the slanted part of the cone. If this were on the outside, you can't see the whole thing. Write the parts that you can see. Go. Okay, what I've done is I've got the normal formula and I've said halve my answer or divide it by 2 because it's half of a sphere. I can't see the circle part of the cone. It's hidden. It's covered by the top of the ice cream. I can only see the curved part of the cone. So I'm only using that part of the formula. Now, there are only 2 letters, R and S. Swap them, write them here. There's your radius and there's your slant. Now, swap the letters for the numbers. Go. If you set it out like that, you are correct. Now, pause it, type it in your calculator, write down the answers. I'm going to put 3 decimal places for each one. If you type it in correctly, you will get those 2 answers there. We've got shape 1, there's our answer. Shape 2, there's our answer. Just like the picture, these 2 shapes are stuck together. Do that final step to your answer, and you'll have your final solution. If you typed it in correctly, you will end up with this answer here. That is the total surface area of those 2 shapes when they are stuck together. All right, thank you. You may now continue on with your questions.